So now let us begin with the concept of simple distillation. So this is the arrangement of simple distillation, cause where you have a jacketed still in which you will introduce your feed, distillate is produced, condenser which is used to convert the vapors into liquid, and these are the receivers to collect the products. Okay, so basically what happens in this process is, first the feed mixture, say A plus B, where A is more volatile component and B is less volatile component, it is introduced into a jacketed kettle or a still. Jacketed arrangement is something like your preheating oven process. Generally you have your ovens right in your home where you preheat them and you go for bake. Before you bake something or when you go for using of them, you preheat them. So some type of similar type of process it is. Jacketed kettle is a kettle which is a heating kettle or heating equipment in which your feed is being introduced. Okay, here you will be supplying heat through the help of coil. The heat is supplied through the help of coil. Okay, heat is being supplied through the help of coil. Then this feed is introduced into a jacketed kettle. This jacketed arrangement is to provide heat to the liquid mixture. Then the liquid mixture is, as soon as it is introduced into this kettle, when the temperature is attained, when the temperature is attained, the more volatile component A starts to form vapors and it is collected as distillate, and the B component is collected as residue after the process. So as the process begins, the vapors will form the distillate which are passed to the condenser, where the vapors will be liquefied and they are collected into different receivers. Now basically in the starting of the process, beginning when the process begins, you will introduce the feed mixture A and B into this still. What happens initially, your vapors start forming when, as soon as, for example, I am taking ethanol and water mixture again, where ethanol is having 98 degrees Celsius and water is having 100 degrees Celsius. So 98 degrees Celsius ethanol is the more volatile component. In initial stages of distillation, whatever the vapors that are being formed will be of ethanol, which is more volatile component. Why? Because initially 98 degrees Celsius can be easily reached. So when 98 degrees Celsius is reached, whatever the vapors that you get will be of ethanol in majority. More amount of ethanol will be there. Some amount of water will of course be there, but more amount of ethanol will be present. So that means in the initial stages of distillation, more volatile component is being formed as vapor. Okay. As the process goes on, as the process continues, the vapors will become less with more volatile component. That means initially at 98 degrees Celsius, majority of the vapors that of ethanol are being formed and converted into liquids by passing to the condenser. But as soon as the process is still going on at 100 degrees Celsius, or if you say 99 degrees Celsius, what happens? The ethanol content will become less in the mixture, right? Initially you have say 50 ethanol and 50 water, you say initially, okay? Initially. So as the process is beginning, as soon as the 98 degrees Celsius is reached, ethanol will start forming vapors. Immediately in the starting stages of distillation. As the distillation proceeds, the ethanol content goes on decreasing, right? Ethanol content goes on decreasing, 50, 30, 20, 10. Then as soon as the temperature reaches to 100, I mean not as soon as 100, you say 99 and all, what is happening? Ethanol content has been decreasing because it is exposed to distillation, heat. So more and more ethanol vapors are formed. So as soon as the distillation is proceeding, ethanol content is decreasing, right? Because it is converted into vapors. So still if you prolong the heat, still if the distillation process continues, you will be getting water also evaporated, because you are not stopping the distillation still. You are still continuing the distillation. So in the initial stages, what happens? Ethanol will be forming vapors, and as soon as the vapors go on forming, as soon as the distillation proceeds, in the vapors, initially you will have more ethanol, but as soon as it is continuing, if the distillation is still continuing, slowly the water also starts evaporating. So in the initial stages of distillation, more volatile component forms vapor, but as soon as the distillation proceeds, the more volatile component composition reduces. The composition of more volatile component reduces as the distillation proceeds. But even that also consists of some amount of ethanol. I mean some amount of more volatile component. That is also evaporating, but even that also consists of some amount of ethanol or some amount of more volatile component, we can say. Such products, the products that are obtained when in the later stages of distillation, where you have less amount of more volatile component in the vapor. That means here in ethanol water, as the distillation is proceeding, some amount of water also starts vaporizing. The stage where this ethanol content is decreased completely and water content is more in the vapor. In the vapor, as the distillation is proceeding, when the ethanol content is decreasing and water content is increasing, in that stage, whatever products that you get, they are known as cut products. The state where you get the product where the vapors are of less amount of more volatile component, will be present. At that stage, whatever product you get, they are known as cut products. These products also consist of some amount of more volatile component. Yes or no? So here in the example you can see ethanol and water we are taking, it is being vaporized. So slowly ethanol is completely been vaporized and some amount of water also is being vaporized. Okay, so as soon as the water content is increasing, even ethanol is also present in the vapor. So even though it is more amount of water, is being vaporized, some amount of ethanol is also present. So during the calculations of the amount of distillate, we also have to consider these cut products. And the mathematical operation used here is differential method. Differential method is used for calculations of distillate. Hence, this simple distillation is also known as differential distillation. The mathematical tool used is differential method. Hence, this simple distillation is also called as differential distillation. This is simple distillation concept. So simple distillation, first the feed mixture is being introduced into the jacketed kettle or a still, where the heating medium is used as a coil. As this jacketed arrangement is because to heat the component mixtures. So as soon as the process increasing, vapors will be formed which are passed to the condenser, which converts the vapors into liquids, and you get the distillate out, and the liquid present here will be collected as residue. Now, as in the initial stages of distillation, the vapors will be rich in more volatile component. More amount of more volatile components will be present initially. So as soon as the distillation proceeds, in the vapors, less amount of more volatile component will be present. So, more volatile component composition goes on reducing in the vapors. So, in the later stages of distillation, the vapors will consist of very less amount of more volatile components. Those products are known as cut products. And even though if it is reducing, the more volatile component is reducing, but even though it will consist of little amount of more volatile component, like 1% or 2% of amount of more volatile components will be present. So during the calculations, even cut products are also to be considered. And to calculate the amount of distillate in simple distillation, we use differential method. Hence, the simple distillation is also known as differential distillation. Differential distillation.